Hey everyone, it's Mr. Wolf, and in this video I'm going to be finishing up Lecture 2, or our lecture on uniform circular motion that we started yesterday. So just to give you guys a little bit of a recap, we talked about this ride called the Cajun Cliffhanger. It was the ride where the floor would give out underneath, and these people would continue to be spinning in a circle as they were essentially pinned to the wall. And even though it might seem or feel like to these people, or if you've been on the ride, that you're being pressed up against the wall, the force is actually pointing centripetally, which means that it's pointing towards the center of the circle. Right? And this is going to be a general rule for any object that's going in a curved path or is traveling in a complete circle, which is that net force. No matter what the circumstance is, whatever the force is acting on it, if it's going in a circle, the net force is always pointing towards the center of that circle. Right? It's pointing centripetally. So if you guys flip to the second page of your packet, you're going to see a similar check for understanding like this. I'm going to go through the first part with you guys. This is really just establishing some terminology that we need to get down. So when we care about circular motion, we're really going to be caring about the forces acting on the centripetal axis. So what's the centripetal axis is we draw a line starting from the center of our circle, and we just extend it towards our object and then outwards as well. So for object A right here at this point in its circular path, there's the centripetal axis. For object B, here's the centripetal axis. And for object C, here's the centripetal axis. So the next question is well, what are we going to say is positive and what are we going to say is negative? So what's positive is always going to be pointing towards the center of the circle. That makes it easy because sometimes my object can be here, the next time it could be over here, and here, and so the center of the circle always changes direction in terms of what arrow that's going. But if we just say positive, we know that it's always going towards the center of the circle, and if it's negative, that means that that force is going to be pointing away from our circle. All right. So here's going to be a quick check for understanding. I'm going to show you guys a video in just a sec, and I'll actually pull it up, where I'm going to be twirling a ball above my head in a circle. All right.
Recording.
Okay. And my question is, quick check for understanding, which direction is the net force pointing as I'm twirling the tennis ball above my head? So hopefully you answered D. The net force is always pointing centripetally towards the center of my circle. So now I'm going to throw a new one at you, and this is going to be on that second page of your packet. Notice number 4, it says, which way does the acceleration point for an object traveling in a circular path? So I'll have you guys take a guess or make a prediction based on what you already know. And the acceleration is also going to be pointing centripetally. So it's going to be D. And the reason being is because net force and acceleration are directly related. And kind of going back to other units that we've done, whatever direction the net force is pointing, acceleration is going to be pointing in the exact same direction. So net force and acceleration point centripetally. Really quickly, since we're on this idea of acceleration, you guys can flip to the last page of your packet where it says important point. And I'm going to just kind of continue on talking about acceleration. All right, so remember, just acceleration is a change in velocity over time. Velocity is a vector. So in order to change, or in order to accelerate, you could change two things. And this is what is on your packet. So the first thing we know from previous units, it's speed. But the second one, since velocity is a vector, which means it has like a number to it, but also a direction, that if I'm just changing my direction, I'm also changing my velocity. And if I'm changing my velocity, I'm accelerating. So I could also accelerate by just changing my direction. Even if my speed is constant, if I'm changing direction, I am accelerating. Right. So now let's go back to the video. So thus far we've talked about net force. We've talked about acceleration for any object moving in a circular path. I'm just using this example right here. The one thing that we haven't talked about is the velocity. And one way we could figure this out is if we just get rid of our net force. So in the video, I'm going to, let's see, here we go. So I'm swinging it above my head, and at some point, I'm going to let go of the ball right around here. So right around here. All right, one more loop. One more loop. All right, so you can see my hand right here that I'm letting go of the ball. So the question is from here to here, I let go of the ball. What's this ball going to do now? And here are your options. All right, A goes tangent, B, it kind of curves along the path, and C, it kind of does this like 90-degree whip around right here. All right, so let's see what happens. I rewind it a little bit. All right, and if that was difficult to see, let's do it in slow motion. All right, and one more loop. Right here I let go. So notice from here to here I've let go, and the ball just continues in that straight path. And if you think about it, that makes sense, because according to Newton's first law, that an object wants to keep on doing what it's already doing. And at this point, there's no net force causing it to change its velocity. So it's just going to keep on doing what it's already doing. So in this case, an object's velocity when it's traveling in a circle is always going to be tangent. It's always going to be looking like this in relation to the circular path that it's traveling in. So I think that's it in terms of the video, but if you guys look on page 19, there's a box that says bringing it all together, and I just want you to answer those questions, or not the questions, but I want you to just draw the arrows for any object traveling in circular motion. What's its net force going to be? What's its acceleration going to be? Which direction is its velocity going to be? And then try out the 3 check for understandings on the bottom of page 19. Thanks for watching.